Hi everyone and welcome to the EOCT Prep series. Today we're talking about SSEF2. The student will give examples of how rational decision making entails comparing marginal benefits and marginal costs of an action. And we're looking at SSEF2A today. Illustrate by means of a production possibilities curve the trade-offs between two options. So let's take a look at this animal called the production possibilities curve. And it looks a little bit like this. So here's a production possibilities curve for hamburgers and blizzards. In case you didn't notice, the DQ is quite popular in my town. So along this line, what a production possibilities curve does is show the different combinations that you can make of two goods. So here, if the DQ did nothing but blizzards all day long, they can make 78 blizzards. And if they did nothing but hamburgers all day long, they could make 98 hamburgers. So that would be the max that they could make. That means that they're not doing anything else. They're not cooking French fries. They're not cleaning tables. They're just making blizzards. They're just making hamburgers. And perhaps a day is a bit of a short time. Maybe if we said an hour, they could probably crank this out. But anyway, given a set amount of time, they can make this many hamburgers or this many blizzards and nothing else. Now let's look at the different points along the PPC and see what they mean. So here, if you start at 98 hamburgers, where my cursor is now, and you move along the PPC to the point A, you're now making approximately 95 hamburgers. When you do that, it opens up space for you, if you look at the line here, to make 14 blizzards. So what happens when you give up 3 hamburgers is you're able to make 14 blizzards. Now notice the trade-off is really high here at the beginning, and that's why the PPC bows out. But imagine in your mind everyone in the entire restaurant trying to make hamburgers. It would be crowded around the grill, people would be in each other's way, and so you'd have a lack of efficiency. If you move just one person over to the blizzard machine, you wouldn't give up that many hamburgers because it's so crowded, but you would gain a lot of blizzards because they're there working the blizzard machine themselves. That's going to change as you move along this curve. So if you move to a further point along here, you'll see that at 86 hamburgers, you now can make 34 blizzards. So when you give up 10 more hamburgers, you gain about 15 more blizzards. That's your marginal cost. To give up 10 hamburgers, your marginal benefit would be 15 blizzards. So what does it cost when you make one more decision? In this case, if you move one more worker from the hamburger to the blizzard station, you would lose 10 hamburgers but gain 15 blizzards. Marginal cost, 10 hamburgers. Marginal benefit, 15 blizzards. And if we move further along here, we're moving into the blizzard section, and now you make 73 blizzards and you would have 34 hamburgers. So you see, to read it, you're going to go across your lines here to the appropriate axis. At the bottom, this dot represents making all blizzards. Let's talk about the dots that are not on the PPC. So when you have a line on the PPC, that means that you're maxing out blizzard and hamburger production. However, you can have a line that's behind the PPC. This line represents what you could make if you're perhaps doing something else. According to this PPC, you are inefficient in any space behind this curve. So here, if you're making 57 hamburgers and 38 blizzards, then you're not as efficient as you could be. You could be up here somewhere making more hamburgers and more blizzards. Inefficiency can mean perhaps one of the workers had to take a break, or called in sick, or came to work late, or there was a spill and you had to clean it up. Or perhaps you're doing something else equally important by making French fries. It doesn't matter. If our two goals on this chart are hamburgers and blizzards and you're not doing just that, then you are inefficient. If you look at point D here on the curve, this point is impossible. Anything out past the boundaries of a PPC is an impossibility. So you cannot, no matter how crushed you are and how many tour buses pull up, you cannot make a combination of 60 blizzards and 67 hamburgers within this hour time frame. So this would be impossible given your current technology. That's a basic PPC graph. There's one other change that you might want to know about a PPC, and that's a change in technology. If, for example, you got a better workflow and you rearranged your kitchen so you were more efficient, you could actually produce more goods in the same amount of time. So your PPC would grow and you would have a growth in your possible output. So now instead of making 98 hamburgers, you can make 109 hamburgers thanks to your new, more productive kitchen layout. You can make 70, instead of 78 blizzards, you can make 86 blizzards. Another way to increase your productivity is to increase your technology. Perhaps you get faster machines for hamburgers and for blizzards, or to increase employee training. So perhaps your employees are trained in the most efficient ways to make these products. Yet another way a PPC can move is if you had a change in technology for only one item. So perhaps you get a new blizzard machine, but not a new machine for hamburgers. Then your PPC would move something like this. That's what a PPC looks like, and hopefully you see that for every decision that you make, if you move and decide to make more blizzards and fewer hamburgers, then you're going to give up something, and your opportunity cost of making more blizzards would be the number of hamburgers that you gave up. Your opportunity cost moving from B to A would be the number of blizzards that you gave up. Thanks. Hope this helped.